In this video, we are starting section 2.1 on sets. Our goals are to define what a set is and recognize when something is an element of a set, define what a subset is and recognize when something is a subset of some set, and then we'll define something called the power set, the Cartesian product, and cardinality. So in this video, I want to talk about what a set is and what a subset is. So let's start with an informal definition, which says that a set is a collection of objects. So let's look at an example. So the example says, let S be the set of SCU faculty members. So as an example, Lavreet, which is my name, I am one of the SCU faculty members, so I would say Lavreet is an element of S. So we've seen this symbol before, which just means is an element of. This symbol with a slash through it means Lavreet is not an element of. Well, Lavreet is not an element of this set A. So let me write A there, because these curly brackets just indicate we're about to write the elements of the set. And I can visually think about the set as maybe like a box or a bag. And the elements of this box are 2, 3, 5, and 9. Okay, so Lavreet is not one of these elements of A. So an example of something that is an A might be the element 5. Something that's not an A might be the element 1. 1 is not one of these elements of A. We have the integers. So the integers, remember our symbol for that is a capital Z with an extra line along the diagonal. So 1 is an example of something in Z. Something like 2 over 7 would not be in Z because it's not an integer. Order and repetition don't matter when we talk about sets. So even if I were to reorder these elements and write C and then A and then B, that's the same set. And if we have repeats, it's still the same. So if I had a couple of C's, maybe I had 3 A's, and maybe I had 1 B, that's still just the same set as this. One way I can sort of think about this conceptually is, maybe the A and the B and the C represent flavors. So this would be, a bag maybe that has 3 flavors. And even if I write something like this, well, there's still just 3 flavors, but there might be like candies, multiple candies that have those flavors. So when we write a set, typically because of that, we tend to write it without repeats, although it means the same thing, even if there are repeats. Okay, so let's talk about a subset. So a subset, if I have 2 sets, S and T, we say S is a subset of T if each element of S is also an element of T. And the way I denote that is we write S, and we write this kind of sideways U, and I put an under kind of line like that, kind of like an equals, and then a T. S is a subset of T. So visually, what would be happening is if I had this shape represent my S, my set S, that is within T. So everything that's within S needs to also be within T. Okay, so let's give some examples. So if I think about this set A, which is this box or this bag that has these elements, one example of a subset of A would be, I'm going to use these curly brackets for notation, would be if I just had 2 and 5. Because each of these elements, the 2 and the 5, are also elements of A. Something that's not a subset of A, I'll give an example, would be, imagine I had the set that has 1 and 2 in it. Because even though 2 is also an A, the element 1 is not an A. So it's not a subset of A because 1 is not, let me put a slash through that, 1 is not an element of A. If there's even one element of my set that is not also part of the larger set, it's not a subset. Okay, so I want to end this video by talking about a couple of different notations in which we can write sets. So the first is what we call set roster notation. In set roster notation, we use these curly brackets, and then within those curly brackets, we list out the elements of our set. So if we write ellipses like this, these 3 dots, that indicates that whatever the pattern is, that it continues. And this is just helpful notation if we have a set, for example, that has an infinite number of elements, like this one does. But anytime I want to use these ellipses, it needs to be clear what the pattern is. So when I see these numbers, 0, 3, 6, 9, and so on, well, it's clear that we're looking at these multiples of 3, starting at 0 and then going up. There's also what's called set builder notation. In set builder notation, we express this using a formula. So what I'm going to do is I'm going to put this curly bracket, and then I'm going to introduce a variable, x, that's going to represent an element of my set. And then I write a vertical line, and the vertical line means such that. The vertical line means such that. And then what's going to follow the vertical line is some description of what the elements in my set look like. So the way I can describe these elements is these multiples of 3 is I could say, well, x is equal to 3k, because that's what a multiple of 3 would look like, where the k is a non-negative integer. So in other words, greater than or equal to 0. And that would be a description of this first set in this set builder notation. As another example, I could have sets that have ellipses on both ends. Like I could also have ellipses on this end. If I wanted to put that in this set builder notation, I could use my curly bracket to indicate set. I introduce my variable to talk about the elements of the set. I write this vertical line. And then now I put my description of the elements, which is, they're still multiples of 3. So I would say x equals 3k. Except because I'm allowing these negative multiples, now this time I would say, well, k this time can be any integer. And that would be my description of my set. One final remark I want to make is, sometimes when we put the set builder notation, instead of writing that vertical line, sometimes we put a colon. And that means the same thing as that vertical line.